Hi, this is Alex from devstories.eu. Deep Agents, Episode 6 of 16. If your main AI agent is reading 10 web pages to answer a single question, it is eventually going to forget what the original prompt was. All that intermediate noise drowns out the instructions. The solution to this is context isolation with synchronous subagents. Think of this as a clean architecture pattern for your language models. When a single agent has access to dozens of tools and runs through long iterative loops, its context window fills up rapidly with raw data, error messages, and tool outputs. This context bloat degrades the model's ability to reason. Instead of one massive agent trying to do everything, you need a supervisor. The main agent acts as a manager. It delegates the messy, token-heavy work to specialists and only receives a clean, formatted final report. People often mistake subagents for an ongoing multi-agent chat room where different models sit around and debate ideas back and forth. That is not the case here. Synchronous subagents are strictly ephemeral. They are spawned to execute a specific job. They run completely autonomously in their own isolated memory space until the job is done, and they return a single final result to the supervisor. Once they hand over that result, they disappear. Consider a specific scenario. Your main agent is tasked with writing a market briefing, and it needs data on recent economic trends. Instead of the supervisor directly invoking a web search tool 5 times and polluting its own context window with raw website text, it delegates the problem. It triggers a researcher subagent. This ephemeral researcher goes off into its own isolated loop. It makes the 5 Google searches, reads the messy results, synthesizes the findings, and writes a single summary paragraph. It passes only that paragraph back to the supervisor. The supervisor gets exactly what it needs, and its context remains pristine. To configure this, you define your specialists using simple dictionaries. You pass these to the subagents parameter when building your main agent. Each dictionary is a subagent specification requiring 4 pieces of information. First, you provide a name, like researcher or calculator. Second, you provide a description. This is the part that matters. The supervisor reads this description to decide which specialist to hire for a given problem. Third, you provide the tools, giving this specific subagent isolated access to things like a web scraper or a database client. Finally, you provide a system prompt, which governs how the subagent behaves. Once you hand this list of configurations to the main agent, it automatically gains access to a built-in tool called Task. The supervisor does not need to know how to instantiate the subagents. When it encounters a problem matching a specialist's description, it simply calls the task tool. It passes 2 arguments, the name of the subagent to use and a plain text instruction of what needs to be done. The supervisor's execution pauses. The subagent spins up, works through its tools, and eventually finishes. To the supervisor, the task tool simply returns the final text answer as if it were a standard function call. Even if you do not explicitly define any dictionaries, the framework gives you a fallback. There is a general-purpose default subagent built in. The main agent can use this default specialist to offload complex reasoning steps. It acts as a blank slate, giving the model a fresh context window to work through a dense logic puzzle without muddying the supervisor memory. Here is the key insight. By enforcing strict boundaries between isolated tasks, you stop intermediate scratchpad work from degrading the reasoning quality of your primary application flow. That's all for this one. Thanks for listening, and keep building.